Hello and welcome to day 2 of the Invasive Shothole Borers Fusarium Dieback 2022 Symposium. I'm Randall Oliver. I am the Invasive Shothole Borers Communications Coordinator based within UCA&R's statewide integrated pest management program. And I'll be helping once again with some of the administrative duties today. We had a great lineup yesterday. I hope you enjoyed that if you were here with us. And today we have an equally great lineup. Starting with Rosie Daggett, Senior Conservation Biologist with the RCD of the Santa Monica Mountains, Max Regis, Deputy Director, and Rachel Burnap, Inspector with the County of Los Angeles Department of Agricultural Commissioner, Weights and Measures, Dr. Karen Jetter, Research Economist with the University of California Agricultural Issues Center, Dr. Shannon Lynch, Plant Pathology, University of California, Davis, Dr. Richard Stouthamer, Professor of Entomology, University of California, Riverside, and then I'll give a final presentation regarding ISHB education and outreach. And so let's go to our first speaker, Rosie Daggett. Rosie?
Good afternoon, everyone. And thanks so much to Randall and the group for inviting me to talk a little bit about how we developed the early detection rapid response plan for Los Angeles and Ventura counties, areas of the Santa Monica Mountains, which is now being adopted and being used by all of LA County. And before I start, I just want to acknowledge that I'm the one who's telling the story, but I have a story to tell thanks to so many people who have contributed to this. And it wouldn't have happened if we didn't have all of these partners and collaborators coming together to give us the information we needed to pull together this EDRR. And I also just wanted to give a shout out to the NASA Develop project effort that is throughout all of the NASA sites. We were able to connect with the location at the Jet Propulsion Laboratory in Pasadena, but the Develop projects are designed to have remote sensing tools be used to help answer questions of concern for various community groups. And the questions that we had concerned really how much had the drought and the invasive beetles impacted the Santa Monica Mountains? Where did they do that? And could we begin to use these remote sensing tools to look at whether or not it was beetle problems or drought problems or both problems? And how do we put all that together? And I also wanted to thank the supervisor, 3rd District LA County Supervisor Sheila Kuehl, who provided the bulk of the funding for this effort, as well as the Santa Monica Mountains Fund and LA County Fish and Game Commission. And all of the folks that helped pull this together were invaluable. You don't get enough money ever in these projects to do the work that you need to do. And to have community volunteers and community scientists participate was crucial to getting the information we needed. So why do we need an early detection rapid response plan? Well, the biggest reason is because we need to figure out what the problems are. If you're seeing a lot of dieback, what is causing that dieback and how do you begin to figure this out? And all of these different elements can be involved in causing dieback in trees. So getting a little bit more information about how to understand this is really critical. And one of the most important things was to look at this from a variety of different scales, from the landscape level all the way down to the individual tree and parcel level. And that's where we really had to rely on our partnerships with the National Recreation Area, landowners, national parks and state parks, and the MRCA. And the study area that we used was the whole Santa Monica Mountains National Recreation Area. And we set up a random grid of 25 by 25 meter plots. And our criteria for selecting where the plots would be set up was colored by their proximity to any kind of sensitive riparian resources, because those were the ones that we felt that were most at risk. And even though oak dieback was what triggered this whole effort, it was really important to look at it from a holistic point of view. And this is where our partnership with NASA became really crucial, because on a landscape level, you really need to look at what's happening and tie things together from a remote sensing point of view, but you have to ground truth it, because what you see on the ground is not necessarily tied completely to what you see from remote sensing. We were able to tie the actual on the ground condition of a given tree to a particular spectral bandwidth on their 240 some spectral band remote sensing data. And with that, they were able to create some really powerful tools to look at how things were changing on a landscape level. And when we put this all together, we were also able to integrate covariates like the number of days of precipitation, number of times we had extreme heat events, and where we were seeing dead vegetation versus live vegetation. And although this is a very busy slide, you begin to see some patterns. And what's interesting is that this that you can see, this is actually the scar of a fire that occurred in 2013, the spring fire in the Big Sycamore Canyon watershed. And it was also interesting to see how our vegetation and drought picture overlaid with fires as well. A couple of really important things came out of this that became sort of the impetus for the supervisor to come back and provide additional funding to develop the early detection rapid response plan. And the two most important things that we learned was, one, we have a really aging forest in the Santa Monica Mountains. We don't have a lot of young recruitment. And while our plots were skewed primarily towards coast live oak, we were able to still take all of the oaks and sycamore tree individual data, plug it into iTree, and begin to look at ecosystem service values. And it's important that ecosystem service value calculations do not include things like habitat value and aesthetic value and ecological value. And it certainly doesn't include removal costs. So despite the fact that we were very conservatively estimating value, it came out to millions and millions of dollars of ecosystem services that we'd already lost. And the second other important piece of information that we got was that although we were seeing high mortality of oak woodlands, the riparian woodland mortality was many, many times greater. And it was a real shock to kind of come up with that quantitative thing. And it really spurred action. And this ecosystem service value cost cannot be understated, because now 5-6 years on, what we're finding is the economic impact, as you know, the folks in the presentations yesterday pointed out, it costs a lot of money to manage this problem. And so the value of trying to figure out where the problem is in an early enough time frame that we can do some kind of effective control is really a good idea. So what is an early detection rapid response plan? Well, we didn't want to reinvent the wheel. And on the left, you can see is the national framework for early detection and rapid response. And on the right, you can see what Shannon pulled together to direct the activities in the state of California. And all of these interact. And what we did was take pieces of all of the things that were relevant to our particular concerns and put them into one plan. And I would encourage those of you who are thinking about developing an EDRR plan for your own location, you don't really need to reinvent the wheel here. You just need to make this, customize this so that it works for your particular location and property. And One of the biggest challenges we had, though, when we first started this, was to figure out who the organizational elements included and how they were to relate to one another. And in the case of Los Angeles County, it was determined that the Chief Office of Sustainability was the linchpin, the hub of the wheel, because they are the ones who interact the most with everyone. And as you can see, there's a lot of players on the field here. So you have, all of the internal departments, Department of Public Work, Parks and Recreation, Forestry and Fire, Sustainability, everybody, flood control, everyone who's in the county dealing with tree mortality related issues. And then you have to get that information to CDFA. And you also need to make sure that you're connecting with your regulatory agencies, all of those environmental agencies that have jurisdiction over any activities that take place in sensitive ecological areas, as well as the public and private landowners and other partners. And trying to organize this to begin with was one of the bigger challenges that we face. And the second most important thing we learned from doing this is that those little boxes are too generic. You have to fill in the blanks with actual real people and actual real contacts in order to make this work and to get it going. So in addition to setting up your sort of framework of who the players are and participants in this planning effort, the actual elements of the EDRR plan are pretty straightforward. You have trapping, visual surveys, action plans, treatment and removal, and these encompass a variety of different nuanced elements. So for trapping, it's really important to do this in a very thoughtful, mindful way. And it is just as important to get information about where there are no problems as well as where there are problems, because this helps you delimit edges of infestation. The other thing that was really helpful was to think about, in our specific project area of Los Angeles County, where are the potential sources and where are the resources that we're most concerned about in terms of high risk. If they got infected, the problems would be really challenging. So, for example, if you get an infestation of shothole borers, like what happened in the Tijuana River Valley, that's a real problem for all of the aquatic resources that rely upon those trees. So you kind of need to get a handle of the geography. So this is the LA County Ventura map. The area that's patched here is the Santa Monica Mountains National Recreation Area boundary. And that is the area we were primarily focused on, but we wrote the plan in such a way that the elements of it could be applied anywhere. And thanks to Max Regis and at the Agricultural Commission's office, he was really helpful in integrating this into the overall trapping effort that the county does. And he and Rachel will talk more about this, but I can't emphasize enough, this is back to the coordination part, because having a big picture trapping effort is a really critical piece of this puzzle. One of the exercises we did for the Santa Monica Mountains is we then went and thought about what were these high risk areas that we wanted to protect and where were the potential source areas for infestation that we wanted to monitor and keep track of. And what you can see here is a map that sort of shows the locations of a variety of different locations that we were concerned about. Anything that is in green is publicly owned lands. So we were hoping to kind of get a better handle of where the infestation was in relation to these wildland areas. And thanks to Rachel and Max, this is the map that they'll get into much more. But I think what's really important from the overall planning point of view is that if you look at this map, reds are where ISHB was detected. Green is where traps were set, but they were not detected. And I think it's pretty interesting to see that where they're bad, they can be pretty bad, but they're not bad everywhere. And so we shouldn't be giving up in despair. We should be really thinking strategically about how we can use this information to better manage distribution. So in addition to the more formal, organized trapping exercise that Max and his team did, the RCD decided we wanted to involve the community. And so we recruited about 40 amazing volunteers, some of whom I think are on this call today, to help us with a randomized selection of setting, sort of DIY traps. And I have to give a shout out to Dr. Stouthamer for coming up with this idea and also for creating the 3D plan for making the connector between these water bottles. This was a really simple tool to use. It was really effective. We used water and soap rather than anything more complex because we were putting out these traps in wildland areas, and we were concerned that if they got tipped over, we didn't want anything to come out of the bottle that would potentially be harmful. And we were able to get an awful lot of information out of this. And I would really encourage you to think about trying to activate your communities in whatever ways you can. And while there are not so many people who are excited about going and checking traps every week, there are lots and lots of people who go hiking every week. And once they become trained and know what to look for, you can really take advantage of the fact that they're eyes on the ground in ways and in numbers of days that we as professionals just don't have time and resources to do. So on this call today, most of you are arborists or land managers, and you're doing exactly what you need to be doing to get yourself up to speed on what's happening with this pest. And this is a great way for you to sort of think about how you can reach out in your communities to effectively engage other stakeholders who are just as concerned as you are about the potential impact to the trees. And I also want to kind of make an important point here that while this was designed for invasive shothole borer and gold-spotted oak borer, these tools are really important for us to be using consistently all the time, because there's going to be another one. We don't know where it's coming from or what it will be, but there's always going to be a new invasive pest. So having these strategies and trainings is critical. And a shout out to Rachel on the right and Dr. Bea on the left for their help in training our community science volunteers, because they did a great job with that. And speaking of new and exciting pests, in the course of doing our surveys, we found these alder trees that looked like they had the measles. And it turned out that based on the identification by CAL FIRE entomologist Curtis Ewing, this was an alderbark beetle that had not been previously known to carry fungal pathogens, but it now is. And this has taken out, acres of alder trees in the mountains. So just to reiterate, the goal of the trapping and the visual surveys is to figure out where the beetle is and where it isn't. And the goal is to get this information to the central location of the UCANR, because they're our hub on this. And figuring out how your organization or you as an individual can get your information to them is really critical. And again, I don't want to underestimate the importance of showing where you looked, but you did not find, because that's super important as well. So how does the EDR plan help? Well, it gives you a roadmap of what to do, who does it, who's going to pay for it, and last but certainly not least is, was it effective? Did it work? Did we contain the infestation? And these rapid response plans come in a variety of ways. They're examples of incident action plans all over the place. We customized ours to be tailored to the needs of LA County. But one of the more important elements of it was coordinating permits. Because if you're going to go in, and as Dr. Kabashima mentioned yesterday, the importance of removing amplifier trees in particular, if you're going to be taking out these trees, we have tree protection ordinances all throughout Southern California. And you don't want to run afoul of these. You also don't want to run afoul of US Fish and Wildlife or National Marine Fisheries or California Department of Fish and Wildlife. All of these agencies that have jurisdictional regulatory authority over sensitive ecological resources. And you also want to make sure that you're doing the appropriate nesting surveys prior to going in and removing a tree. So there's lots of things to think about. And if you have it all kind of organized, if you've met with the representatives of those agencies, you've laid out a plan of action of response, then you can just jump to it when things happen and not have to go through all that organizational administrative stuff. It also provides a really great tool for institutionalizing best management practices and treatment and removal protocols. When do you take out a branch versus a whole tree? When do you make a choice to use some sort of insecticidal treatment? Where is that appropriate? When and how? If you have this all mapped out, it's a menu. You can pick what you need, given whatever the site-specific things are. The other thing that's really important here is outreach. And I cannot overstate the fact that having these conversations with the permitting agencies, the planning departments, all of the groups that are involved in this kind of tree response, and doing it when it's not a crisis, when you're just kind of getting yourselves together to figure out how you're going to make it work, works really well. And, you know, we as humans are very responsive to crises. We don't like to plan ahead. But in this case, it makes a lot of sense to do that because it just makes it a much smoother effort when you have to go start removing trees. Another part of this is that if you talk to the permitting agencies ahead of time, almost all of them have mitigation requirements for what you're going to plant, where you're going to plant it, how long you're going to take care of it, and all of those kinds of things. And by having plan in place, everybody knows what the story is, and it doesn't change dramatically. And this gives you a level of certainty to work with in terms of budgeting so that you can figure out, okay, I got a grant to take out these trees, but I don't have a grant to replant the placement trees and monitor and care for them so they survive for the 7 or 10 year requirement. So again, it's a way of sort of thinking ahead and organizing so that things go and proceed smoothly once you have a problem. And the last tab on this slide is probably one of the most important, and it's the one that gets the least looked at. And that is, how do you know if you've done a good job? Is it working what you're doing? Is removing these amplifier trees actually reducing the level of infestation? Do we need to do more? And by having a coordinated, organized way of reporting and discussing this and checking in to see what works and what doesn't is a really important thing. So for the reporting tools with community, you can use like an iNaturalist project, you can use Survey 123, but then that data has to go somewhere centralized. And in LA County, we're sending it to the LA County GIS information systems folks and to Max at the Agricultural Commissioner's Office. And they're the ones who are connecting with UCANR. And so having this multi-tiered organizational approach is really great. But if you are managing a golf course and you aren't submitting your data, or you're the Southern California Edison lineman and you're arborist and you're not reporting your data, then that doesn't help. So again, please take the time to share with what you learned. The EDRR plan in LA County was adopted by the Board of Supervisors in 2020. But it has actually taken these 2 years since that the plan was adopted for the county to really wrestle with those internal organizational things and come up with a strategy for what kind of staffing needs are required to make this work. And even though we know that doing this will save money in the long run, it still costs money upfront. So figuring out how to fund that and how to appropriately fund that has been a real challenge. But thanks to Chief Forester Ron Durbin and Max and the Office of Sustainability, the request for funding is going before the board in this May. And hopefully they will get the funding they need and we can really get this thing up and running. So I'm going to end with just one more plea for at least trying to get visual surveys going in your community, on your property, whatever land you manage. And whether this be with your employees or with community volunteers that you engage, these visual surveys are invaluable. And please feel free to go to the RCD website, and anything that we have on our website that is about bad beetle training for communities, feel free to take and use. Customize it as you need to, and share it around. That's what it's for. And we hope that you'll find it to be helpful in setting up your own effort. So I'm going to end with just one sort of thought, which is that we're all here because we care about the trees, we care about our landscapes, we care about our communities, and we care about how all these pieces fit together. And so I just want to thank you for all the efforts that you individually do, wherever you are, in whatever your community, however you define that, because it's only by all of us coming together that we're going to be able to handle the invasive shothole borer, the gold-spotted oak borer, and all the others that come our way. Thank you very much.
Thank you, Rosie. We do have a couple of questions, and you've got a few minutes to answer them. Our first question is, how do you correlate each dollar sign with actual value on your scale? Is it just a qualitative look at the overall costs or something else?
Actually, what we did is we used the iTree, which is available online for free. And you just go and you select various characteristics about each individual tree that you want to estimate the value of. And it's like magic. They have the algorithms all set up. And so you get a value spit back to you. So we did this for all the trees that we had actual real information on, like their DBH, their height, their location in relation to other buildings or other things that are part of the questionnaire on iTree. And because most of our trees that we were looking at are either in a wildland, public open space, or on the wildland urban interface zone, some of the electricity things and temperature things are, it's all very conservative. So the numbers that we came up with are really very low in response to what the actual cost to us as a, as a civilization for the loss of these trees. Hope that helps.
Second question, based on the data, can you estimate what the rate of spread was in the Santa Monica Mountains?
So we actually didn't do that spatial analysis because we really only had like a few detections, and they were all located along the urban wildland interface. And we did, just in the case of Calabasas, it was really close to an urban wildland park that was owned by and managed by an HOA. And that was the center of spread, but we didn't do it as an overall look. But Max and Rachel are going to talk more about the trapping, and their information is probably more detailed to provide that kind of information.
And I think we'll actually delay the other question that we had, perhaps for them to answer. Just a question about how an HOA can get traps if they have low infestation and say one amplifier tree. So thank you very much. And with that, let's go ahead and bring on our next speakers. Max Regis, Deputy Ag Commissioner, and Rachel Burnett, who is the Associate Inspector, both with LA Agricultural Commissioner's Office.
Thank you, Randall. And hi, everyone. My name is Max Regis. I work for LA County Agriculture. And I wanted to start this discussion by showing you this map, because I think it's going to highlight what we're working with and what we're dealing with. So what you're looking at right now is our trapping season from last year. As you can see, the insect is widely distributed throughout LA County. We deployed 2,400 traps, and the insect has been found throughout the county. The red boxes are the traps that yielded results, and the green traps are traps that did not have any insects on it. The gray ones were either lost, stolen, I'm not sure what happened to them. So as you can see, the insect is pretty widely distributed. There's some areas of infestation. We heard Santa Monica. We can zoom in there really quick. Santa Monica Mountains. And that's a look at what we found. For the question for the HOA, before we get to the presentation, call our office and we'll send somebody out to play some traps. That's how you get our attention, and that's how we can help you out with trapping. If we gave you the traps and you placed them yourself, the identification of the insect is somewhat complex. And these are sticky traps. So it's best that we take the trap, put it out, deploy it, and then bring it back to our lab to study it. So with that eye opener of a map, let's start our presentation. All right. So that's a picture taken of the invasive shothole borer by Dr. Eric Kelly, who's our entomologist. And what we are here to talk to you about is some of the steps that LA County took or has taken to combat this insect. Now, as you have heard, the insect was most likely introduced in the early 2000s, and it's now 2022. So why is the response so slow? Well, initially for the agricultural commissioner, this was not considered a pest that was an agricultural pest. So we were not working with this particular insect. We knew that it was out there. We did not know its spread. We knew it was causing a lot of damage, but we were not able to take action. So in 2018, through the work of Dr. Kawashima and his urging of the commissioners throughout the state to do something, and he went out and got us some legislative action and also some funding to do this work, to do research, and to continue to mount some sort of fight against the insect. So with that, there was a component in which we deployed the traps. That's the map you saw earlier. We have performed tree surveys. So the trapping alone only gets you so far. It lets you know that there's an infestation there, but then you have to put boots on the ground and determine where those amplifier trees are. Once we determine where they are, we then go about removing them. And that has been done with a grant that we acquired from CAL FIRE. That grant is due to expire next year, and we are working with them to get another grant to continue to do this work, on top of the funding that we might get from the county as well. So all these actions are science-based. A lot of our work is riding on the work that was done by Rosie and by John. So they did all the sort of thinking and putting these protocols together, and we're out there and employing them and using them for this insect. All right. So as Rosie mentioned, the EDRR was published, and it gave us a guidance on how to proceed with this. A lot of times when we're determining how to proceed or who to contact, this is sort of our remember the yellow books? It's our yellow book. We can look in there and see, okay, which department do we want to talk to? Who might we need to go address and talk to for permitting? and utilize it that way. So it has been a great tool for us. So what has the county been doing? We did the trapping. We started doing tree removals at one of our major parks, and Rachel is going to go more in depth with that. But what we managed to do is, through the meetings that were held to put together the EDRR, we were able to meet all the other departments that are within the county. So believe it or not, government is very fragmented, and I might be here in Ag Commissioner office, but I'm not talking to the people over at Parks and Rec, or I'm not talking to the folks in Public Works or Beaches and Harbor. All those agencies are tasked with maintaining trees, but we didn't have any connection or communication amongst us. We have that now. So we're able to work with these other departments, share information, share best practices, and also, when needed, assist them with removing trees. All right, at this point, I'll pass it over to Rachel to continue to talk about some of the projects that we have worked on.
Hi, can everybody hear and see me? Okay, cool. Well, my name is Rachel Burnap, and I'm an inspector for Los Angeles County Agricultural Commissioner Weights and Measures. And along with Inspector Fayek Gergis, we have been doing tree surveys throughout the county. Basically, we are the boots on the ground, and sometimes we also get stuck in the traps. I had to try to pull a joke. So with the passage of the AB 2470, the big question for us was, in a county with more than 4,000 square miles and over 160 county-owned parks, where do we start looking for a beetle this size of a sesame seed? And we decided at ground zero. Whittier Narrows Recreation Area is in the town of South El Monte, and as Max and many others have already mentioned, it is the place of ground zero where the polyphagus first was found. And I'll be talking about some of the completed projects and surveys that we have done. So here's a quick background on Whittier Narrows Recreation Area. It is owned by Los Angeles County Department of Parks and Recreation. And Max, can you forward it to the map, please? The Whittier Narrows. Here we go. So it's divided essentially into quadrants between the Rosemead Boulevard / Highway 19 and the 60 freeway. It's one of the county's largest parks at 1,500 acres. Plus, it's an ecological gem because it's nestled in between the confluence of the Rio Hondo and San Gabriel rivers. The invasive Chahobor tree survey that we completed at Whittier Narrows started roughly around October 2020. We already knew that it was there, but we didn't know the current state of the infestation. We also knew that there were trees that had either died and remained as dangerous snags there, or trees that were active amplifiers. And it was a perfect place to start looking. So we started in area B, which is in the northeast quadrant of the park. In this section, we took a look at basically every tree there. And we took baseline data and mapped every infested tree. In this area, there's about 215 mapped GPS points of trees. We collected baseline data regardless of action needed or level of infestation. And that's why you'll see so many points in area B. This took a while, so for the rest of the area of the park, we decided that we would do a quick triage of each tree, and if it was heavily or severely infested or was dangerous, we then would map it and collect baseline data for it, resulting in fewer data points. We also collected, of course, the Fusarium samples for these trees. So here at Whittier Narrows, we found that the primary infested tree were either London planes or native California sycamores. We did find a few cottonwoods that were infested, along with 3 dead Chinese elm trees that exhibited amplifier entry hole numbers, as well as 1 golden rain tree that had also died with over 150 entry holes. But amazingly, other areas of the park with reproductive hosts were left untouched. For example, around Lake, we found large DBH cottonwoods that were left untouched by the beetle. We weren't quite sure why. Go back to the earlier slide, Max, please. Oh, thank you. So here we found 159 amplifier and or hazard trees that had been infested. We also found 35 trees that needed to be trimmed. And of course, we mulched all the infested wood down to 1 inch, solarized it, and after the lengthy time of solarizing in the sun, we used the mulch on site. And for this, I have to give a lot of credit to the San Gabriel Conservation Corps for spreading and managing this massive mulch site. So here we found a lot of the sycamores had been recovering. And of course, we found the classic grove of many sycamores in recovery with that 1 or 2 heavily or severely infested amplifier in the middle of the grove. And of course, as we all know, by removing the amplifier in the middle of those recovering groves, we are able to help those trees continue to recover. Early records from the reporting entomologists early in, I believe, 2005 noted that the black locust and box elders were becoming severely infested there. During our 2020/2021 survey, we did not find any box elders. We did find 1 black locust, a large DBH1 that was severely infested, and you could see the large limbs had been dying and getting cut off over the years. So now, can you continue on to the, you know what, I'll go ahead and talk about the rest of the completed projects, and then we'll go back to the map, heat map. So another project that we have surveyed, but the removal of trees has not yet been completed, is at Devil's Gate Reservoir in Pasadena. This site is owned by Los Angeles County Department of Public Works, and it is a native habitat area where they have restored it. Here we found 5 amplifier trees to remove and 1 cottonwood to trim. The infested species here are varied and included black willows, cottonwoods, a couple of sycamores, and 1 box elder. There was a small forest of dying or dead black willows that we examined. It was originally thought that they were killed by ISHB. However, at closer inspection, there wasn't enough entry holes to show that Fusarium dieback had been the reason for mortality for those trees. So those trees must have died either to drought or perhaps some pathogens, other pathogens had continued to make the stress trees decline there. One interesting note about these black willows and kind of this dried out riverbed is that the Fusarium, as we dug into a few of the entry holes, we found that the Fusarium became drier and drier, almost as if the dry conditions of the tree had almost stifled the Fusarium growth and the beetle reproduction. 20 of 21 during April, the Los Angeles County, the trappers put out 2,490 ISHB traps throughout the county. And that's the map that Matt was showing. They were left for 1 month and retrieved. Unfortunately, 329 of these were missing. 1,530 traps had no beetles. We did find 631 traps had beetle samples in them that we sent to the CDFA for analysis. 554 came back positive, which is a pretty good positive rate for the amount that we sent to the CDFA. And of the retrieved and the ISHB positive traps, approximately 33% of them had 1 beetle. And the highest beetle count that we found, a hotspot, was 207 near the Puente Hills landfill or near the city of Industry. Also continue to survey the county parks, some of the other projects, open spaces and parks where the trapping results in our heat maps show high ISHB counts. We also respond to homeowners and other entities' requests for tree surveys and education. A survey request. Aha, there's my heat map. There you go. Okay, let me finish this first here and we'll talk about this map here. So we respond to requests from homeowners, arborists, cities, other entities to take a look at their trees. This is extremely, extremely important, and one that we greatly appreciate is that homeowners have told us about new infestation sites. And the 2 green dots that you can kind of see near Topanga State Park, those are new local zones of infestations that were brought to our attention through a resident. And of course, we are also continuing our list of trees that we can remove using the CAL FIRE grants. And of course, we have all the permitting processes that go with it. And now let's talk about this heat map. So we took the data, the ISHB trapping 2021 data, and we magnified it according to the ISHB counts found in each trap. So you can see where our hotspots are in the county. Now, if you take a look at the kind of the light green dots, you can see where we have visual confirmation of the trees. And interestingly, in some areas, they do correspond. You have, of course, Whittier Narrows, where there's a bunch of green dots. And you have, of course, there's Pasadena and the upper large yellow area, but areas out in eastern Los Angeles County don't quite correspond. So the big lesson here is just because it wasn't caught in a trap doesn't mean that the beetle is not there. And remember, a lot of these places, we don't know. We just don't know yet. It's such a big area to survey. Slide, please. Okay, and with that, I'm going to pass that over to Max so he can talk about some of the other projects we will continue on.
Thank you, Rachel. So as the county moves forward with this work, we're going to continue to do trapping throughout the county. Some have asked why, because we already did some trapping, but it is interesting to see the progression of the insect and also in the areas where traps were either lost or stolen to go back and reassess those areas. So the trapping that we're embarking on now, it's a bit more focused. So it's not going to be county-wide, it'll be project-based. Also, we will continue to work with the new partner to this project, which is the Chief Executive Office of Sustainability within the county. And that office has come in and has helped to organize all of us, and they're sort of the group in charge of all the departments working together. So through those coordination efforts, we'll be able to better continue to work at removing trees and work at identifying infestations. We're also going to continue to work with some parks that Rachel surveyed with another inspector and work on packaging that so those trees can be removed. The process entails us taking samples, getting positive confirmation, finding the right time of the year to do the work, and then taking down those trees, mulching them, and absorbing the mulch. So that the process can be lengthy, but we're starting to do that at other parts as well. The next step that we're working on is the sampling, since a lot of agencies in the state are doing this kind of work, sending them to CDFA, California Department of Food and Ag, that lab has become overwhelmed. So we have discussed in-house whether or not we would be able to stand up our own molecular lab and be able to process some of the samples ourselves. And we have the know-how, we have the funding, and we're about to move into a new lab. So all the conditions were right to proceed with this work. As we speak, we're buying equipment, and we should be in our new lab by May and functioning by July. So that's an exciting development because it'll help us streamline the identification process of the Fusarium. We don't have to send it to the state. We're going to continue to look for funding. I'm always knocking on doors and asking, can I have some money? I feel like I'm back in high school. Mom, can I have some money? So with that, we're going to continue to go to other agencies like CAL FIRE and ask for funding. There are additional pathways of funding that I just heard of yesterday that we're going to explore. And I'm not at liberty to discuss yet, but there are interesting ways that we are requesting and getting funding. And lastly, we're going to continue to work with UCA&R, arborists, and all the other folks that we've been working with, scientists, et cetera, so that we can continue to share our results, continue to gather information from them, and grow together as these projects move forward. Okay, next slide. So outreach. It has been great that we've been able to do a lot of outreach to the Santa Monica Mountain communities. That has been put together by Supervisor Kuehl's office. So thank you for that help. It's been great. Through those outreach efforts, we are getting trees reported to us. So if you're an agency that is wanting to embark on something like this, definitely try to do as much citizen and outreach as you can. Try to do as many presentations as you can. We found that sometimes when you do them during regular office hours, it doesn't work for folks because they're at work too. So you might have to do them later in the evening. So little things like that will help you be able to better spread this message. And again, as soon as we get a homeowner request or management company, municipality, whoever it is that they're asking for us to come out and do an inspection, we go out and we try to go out there as quickly as possible and take samples and determine what's going on. To everyone in this meeting, we'd also like to share that we have our own in-house entomologists and plant pathologists. So if you are in need of an insect identification, feel free to reach out to us and we can help you with that. We can help facilitate that. Mind you that these will not be official samples. These will be samples that will be identified by our plant pathologists and entomologists. But if you need an official confirmation, it has to go to the California Department of Food and Agriculture. And here's our contact information. And this presentation will be made available so you can get it from there. And in closing, I want to share that inaction or doing nothing was really not an option for us. And we saw that the problem was here. We just didn't have the tools and the funding to do the work. Once that came in play, we were able to begin doing the work, and it has been very rewarding, and we feel like we're making a difference. So if anybody has questions on how to start a program or anything like that, feel free to reach out to us and we can help. And thank you for your time.
We do have a couple of questions in the Q&A. So one question is, if a city asks you to do a survey or trapping something, do they pay your organization for that? And this individual is also wondering if LA City Recreation and Parks ever asks for assistance.
So the first question, if a city comes to us and says, hey, can you take a look at these trees? No, we do not charge for that work. And we're working with the city of Lakewood right now to remove some trees that Rachel identified. So we'll go so far as to actually also pay for the tree removal if the funding's still there. So one of our projects that's in queue right now is to take down about 11 sycamores in the city of Lakewood. So yes, we would help you, and if we can help you with the removal, we would help you with that as well. As far as the city of Los Angeles, we recently started working with Rachel Mallory, and we are trying to see how we're going to coordinate that. But they're also a large organization that has their own in-house specialists, so they're able to do a lot of the work themselves. But we're open to helping when we can. And the next question.
The other question was one that was asked earlier regarding an HOA if they suspect that they may have Chahobor, may even have a single amplifier tree. How do they go about requesting surveys or traps for their community?
Yeah, so it would be the same mechanism. They would contact either Rachel or myself, and then we'll schedule someone to come out and take a look at the area of concern, take samples, and then let them know what we found. And if we can help, we would also be able to utilize our grant money for that work as well. There are no limitations on what we can do with our grant funding as far as where we will remove trees. We can remove trees in private homeowners' properties, cities, county-owned facilities. So we're not restricted to where the tree is located.
Okay, that's all the questions that we have in the chat. Our first presenter for the next section is going to be talking about environmental and monetary costs of invasive shothole borer and other invasive species. This is Dr. Karen Jetter, research economist with the University of California Agricultural Issues Center.
So this is a collaborative project that was done with a variety of researchers at other institutions. This included people who worked with GIS mapping at the Information Center for the Environment at UC Davis, UCE Cooperative Extension at Orange County, Plant Pathology at UC Davis, people with the US Forest Service, and Natalie Love, who worked at Cal Poly San Luis Obispo, where they maintain a database, street tree inventories for the state of California. And so this was, everyone contributed a piece to the analysis for this project. So a little bit of background. This is a policy analysis we did, and it has to do with the entry of exotic pests into new areas that can have large economic consequences because natural enemies that manage it in its natural environments are often missing in the new environment. And so when the pest enters, its infestation and damage are normally localized. And so they will receive scant notice by the people affected, and there'll be very few calls for treatment. But as the pest spreads, however, the damages increase exponentially as the pest invades in all directions. And as damages increase, public awareness increases. But now the cost to manage the pest to prevent damages are also higher. And so that is what we want to prevent. And so we want to have this early detection and monitoring systems in place. This is one of those programs that when it's successful, nothing changes. You don't see benefits accruing, you don't see costs accruing, you just see that nothing changes in your environment. And so it is difficult to demonstrate these benefits to a public when their attention is going to things where they are observing costs in their life. And so we wanted to look at costs and benefits of a monitoring program to see if it makes sense to have a monitoring program, or under what conditions would it make sense to have a monitoring program. So this study estimated the costs and benefits of alternative programs to monitor and manage the invasive shothole borers. We evaluated different levels of damage due to the spread of ISHB. And we looked at tree death was what we looked at. We did treatments at this time due to it was sort of beyond the scope of the project at this time, but that, just hearing all the presentations over the last couple of days, that's moving forward. That's something we should definitely consider. But so the levels of damage and tree death due to the spread of ISHB, we leveled it by 10 percentage points in increments from 10% to 70%. And a wide range was picked because we're not really sure what exactly is the percentage of tree death that's going to happen. And this allows a wide range for us to look under what conditions it would be a good idea, and under what conditions the benefits of a monitoring program would exceed the cost. We evaluated 2 monitoring programs, one valued at $400,000 a year and one valued at $500,000 a year. And this was based on some feedback from county ag commissioners' offices and some other organizations that were managing ISHB and sort of what their costs were to monitor and survey for ISHB in their districts, but also what they would like to have their budgets be in order to do a better job monitoring. And so that's where that number came from. And we did our preliminary analysis of only Orange and Ventura counties. So the annual costs from the invasive shothole borer transmitted disease are equal to the cost for the tree removals, lost ecosystem services, and we also used iTree Eco for that. And those ecosystem services included pollution abatement, carbon storage, annual runoff mitigation. And then we did, for us, because we were looking at landscape trees in the urban environment, we did also calculate the lost landscape asset values of trees. And that is what is evaluated in iTree Eco, and then the cost to replant. We looked at a 10-year time horizon, and the annual costs are discounted over the 10-year period using a discount rate of 5%. So for those of you who like to see the math, here's the math, and we just sum the costs from the different activities and then discount it over time with the discount rate. So removal costs were obtained from surveys of local arborists who manage public trees and were averaged across the different arborists. Ecosystem services and costs and landscape values are estimated using a program called iTree Eco. And we did it using street tree inventories and plot data. So the people on our team who were from the Forest Service, they were able to access the Forest Service plot data and the location of the individual trees in that plot data. So we were able to use that in iTree Eco. Replanting values were estimated from the landscape asset value equation, which included a term for the price of the largest tree that can be planted. And so we just solved that equation for the trees in which we had full information. Monitoring costs were provided by local agencies as described earlier. So the main variable that we had to figure out was how many trees would be affected. And there are no data available on total number of trees in an urban setting by species. And so we extrapolated from the street tree inventories and satellite canopy data in order to figure it out. So the street tree inventories provided information on the share of trees in the inventory that are susceptible to tree death due to the spread of the Fusarium dieback. And so here is the graph of how the data was used to estimate the total number of trees in the environment. So everything that is a green circle, that is a canopy photo. And so this was from the satellite that looked down and said that this is just vegetation, but it doesn't say what that vegetation consists of. And then the X's in this map are trees from the street tree inventories. And this was an inventory for Laguna Woods in Orange County. And the city of Laguna Woods is mostly a retirement community. And so the community maintains an inventory of all the trees on its property. So they had a complete inventory for Laguna Woods that we were able to use. And then they were able to count the number of trees per square footage of canopy cover, and then extrapolate it out from that to estimate the total trees in Orange County and the total trees in Ventura County. So to just summarize, we have the share of trees susceptible to tree death from the inventories. We estimated the total number of trees in each county. We had assumptions on the number of susceptible trees that would actually die as a result of ISHB. And we just need to model how it would spread over the 10-year time horizon. And there are different ways to do it. And this was a function that we used that had symmetry in how fast it spread and how fast it declined. And so this is the share of trees killed during every year. And it reaches its peak in year 5 and 6, and then is lower in years 1 and 10. And so the estimated tree populations and tree death in each time period is then equal to the spread from that graph, the share susceptible. So these are the results that we got. So for Orange County, our inventories included 559,074 trees. There were 17 inventories available for Orange County. The count of the ISHB killed competent trees, these are the trees that are susceptible to death from the FD, was 48,000 or 8.63%. The estimated total trees in Orange County was just over 5 million, which meant that there were 439,000 trees susceptible to death from FD. So then from Ventura is not as urbanized as Orange County, so there are fewer trees. We had 4 inventories for Ventura, which pretty much covered the main urbanized areas in Ventura. 14,000 trees were susceptible, or 10,000, so there's certainly more trees in Ventura than in Orange County. The estimated total trees was 2.4 million, and so the number of estimated trees susceptible to death from ISHB-FD complex was 263,000. So our results, the average cost per tree removals was $603 per tree in Orange County and $597 per tree in Ventura County. Ecosystem services, this is the pollution abatement, the carbon sequestration, and the irrigation runoff, was $68 per tree in Orange County and $65 per tree in Ventura. Replanting costs were about average to $250. The asset value that comprised the main value for trees in both areas, it was about 70% of the total value. And this is just because we like having trees in urban areas, and that is the value of the average tree in the 3,665 is the value of the average tree in Orange County, and the 3,819 is the average value of the tree in Ventura. So the average value total was about $4,600 in Orange County and $4,700 per tree in Ventura County. So here are the results, and the number of trees varied, and this is over the 10-year period, from about 43,000 with 10% died to about 307,000 if 70% die. And in Ventura, it varies from about 26,000 over 10 years to 184,000. So the removal costs, of course, vary in relation to the number of trees that die. Ecosystem replanting costs, total costs vary from about 156 million in Orange County when 10% trees die, up to just over $1 billion in Orange County when 70% trees die, and from about 96 million in Ventura County when 10% of trees die, up to 675 million in Ventura County when 70% die. And again, the numbers in Ventura are lower overall than the numbers in Orange County, even though the value is a little bit per tree is higher in Ventura because Ventura just has fewer trees than Orange County. So how do we compare this to the monitoring costs? So because we have that symmetrical spread, it turned out that if you lowered the percentage of trees that died as a result of the Fusarium dieback, and you made it a change was 10%. So this could be whether it went from 20% to 10% or from 50% to 40%, was 156 million for that 10 percentage point change. And so we looked at that difference, that if we could, with the monitoring program, for example, change the incident of tree death by 10 percentage points, those benefits were 156 million over the 10-year period. If there was a significant change, for example, if there was a 60% change, a 60 percentage point change. So if it, for example, the incidence of tree death went from 70% to 10%, then the benefit per percentage change was 935 million over the 10-year period. We took the present value of the monitoring costs, so the present value over the 10-year period. When monitoring costs are 400,000 a year was 3 million, and at 500,000 a year is 3.86 million, which gave us a rate of return that varied from $50.45 at 400,000 a year to 40.36 at 500,000 a year for 10%, and this is in Orange County. And of course, it just goes up from there to hundreds of dollars in benefits, depending on how far the percentage change is. Similarly, we see the same results, similar results for Ventura County, that the benefits go from 96 million to 578 million. The costs again are 3 million to almost 4 million. We always get a positive rate of return. And so it doesn't, in all scenarios that we looked at for this, the benefits of a monitoring program are always greater than the costs. But just conclusions, due to the size of urban forests, the entry and spread of invasive pests and diseases can cause significant damage. Early detection is essential to managing the damage and costs of invasive pests. And then for damage levels ranging from 10% to 70% of susceptible trees dying from ISHB and the Fusarium dieback, and monitoring costs of 400,000 to 500,000 a year. In all instances, the benefit of monitoring and managing invasive shothole borers early on are greater than the costs. So if there are any questions, I'll be happy to take them.
I do see one question in the Q&A. It says, can't success of a monitoring program be related to pests located? Or is there it assumed that the spread of the pest X, whatever that is, was halted?
We assumed that in 10 years that the pest had spread fully throughout the environment. So that's a better way to say it. That by the end of that 10-year period, it really had nowhere else to spread. And so that's it. You know, that's something that as we move forward might be a good thing to simulate, and that we can spread out that time horizon and say, no, it's not 10 years, it's probably more like 15, 20 years. But that is, that was more the underlying assumption, was that it had completed spread rather than that the pest was halted.
Can you say what factors contribute to the value of the tree itself?
Ecosystem services or the landscape values?
The landscape values.
So the landscape values, it takes the diameter of breast height, that value, so it depends on how large the tree is. It depends on what species the tree is. There are some species that have a higher value than other species. It depends on its location. Is it a straight tree, or is it in a yard, or is it in an open space area? And there's something called the condition factor, and we used an average condition factor in our analysis, and the replacement cost. And so the value of it the numerical figure is based on the value of the replacement cost.
All right, thank you. I'm not seeing any other questions in either the chat or the Q&A at this time. So thank you for your presentation. And I think we'll just keep this moving and go on to our next speaker, Dr. Shannon Lynch, who is with the Plant Pathology Department at UC Davis.
Hello, everyone. Thank you for having me today. It's so great to see such a well-attended symposium and see so many familiar as well as new faces here on the call. So I am actually going to talk about a couple of things today. I'm going to be talking about our work on endophytes and how we're working towards moving towards using endophytes to hopefully control the Fusarium pathogen that's carried by the beetles. And then I'm also going to talk about some work to predict Fusarium dieback invasive shothole borer establishment in California. And so I just want to acknowledge all of the co-authors here on this slide. It obviously takes a village for this work to happen. And so I just want to give a nod to everybody involved here. It's multi-campus, multi-agency collaborative effort. So diving right into the host microbiome and so when we're thinking about the host microbiome and thinking about forest health in general, so the tree microbiome is known to play a role in protecting plants against pathogens and herbivores. So just like our gut microbiome has a role in our overall health. And the idea is that the microbiome is all of the fungi and bacteria that for us, let's say in our gut, that we have that are living inside of our gut. Some of us have different species and different numbers of species in there. And, like when you eat yogurt, you're getting all of your probiotics. And the idea is, some of these trees are going to be getting more yogurt than others. When we're talking about the endophytic microbiome, what we're talking about is fungi and bacteria that live inside of plant tissues. And so because they have a role in plant health, these communities can also be an indicator of forest health more broadly. So understanding how the microbial communities are organized and how they behave can help us better understand how disease works in these systems. These endophytes can therefore be affecting variation in disease outcomes. So these are, just to give you an example, these are two pictures of planted sycamore trees that were taken at the same location in this disease hotspot in March and November of 2016. And so the trees with the yellow arrows were infested, but they got better. The trees with the orange arrows were also infested, but they got worse. And then some never got infested, which are indicated by the white arrows. And this could just simply be that the trees are susceptible, but they just haven't been infested yet. But because these are planted trees with a similar genetic makeup, we were thinking that another possibility for this variation is that the endophytic communities in these non-infested trees may be contributing to whether or not a tree is susceptible or recovering or preventing infection in these trees. So to understand how the microbiome may be leveraged for control, what we first have to do, and what this is the first phase of the project, is we need to take a step back and see what the endophytic communities look like and what role is for the different kinds of microbes that we find. And so this is just showing, these are Petri plates of endophytic communities that we cultured from different trees. And you can see that they are different in the kinds of species that are growing on those plates and the number of species that are growing on those plates. And so what we did was we asked this question, we want to know first, do the communities differ among different host species? And the other question then that's really that we want to address is, do the communities differ between diseased and non-diseased trees within each of these species? And so if we can identify differences, then we can get a sense of what might be causing those differences. So quickly, there are two important ways to study these communities. So there are culture-based approaches where we place plant tissue into media and Petri plates and we see what grows. And then there are metagenomics, the most widely adopted, and what we have adopted here is called metabarcoding. And that's just using this high throughput sequencing of DNA from samples to identify members of the communities. And so there's sampling biases in both of these approaches, which is why we use both of them to complement one another and account for those different biases. I'm going to be focusing on what we did in the culture study today. So we have up here in this right corner, this is our network of monitoring plots. I'm going to get into more details about that later. But basically, this amazing team that I have here, we went out, we sampled wood from 1,200 diseased and non-diseased trees in this representative subset of our 260 plot network. We had a very dedicated team. We basically cultured these endophytes. We cultured a subset of those endophytes, so 575 samples in 88 of those plots. As you can see from the stack here, it takes time and space to do all of that. And we also extracted DNA from all of the wood samples that we collected for the metabarcoding work. And this graph is just showing, just to give you an overall thing, this is not on the test, but this is basically just looking at the fungal diversity at the family level with the total number of isolates or strains that we recovered within each of those families on the x-axis. And we found this huge diversity of fungal endophytes across the host species. We got a total of 771 strains, and this is just kind of what the distribution looks like. And we also recovered a whole lot of different kinds of bacteria as well. And this is just looking again at the distribution of those species. We collected 650 strains that were, dominated by some bacteria species and had less representative others. But this really covered both with fungi and bacteria. We really got the breadth of diversity within each of these kingdoms, which was really cool. So we then did an analysis of everything that we cultured to see if the endophytic communities differed among host species. And this graph is basically just showing what those differences look like. And the first thing that we see is that there is this strong separation between the avocado species in the black. So basically, if things are closer together, they're more alike. If they're further apart, they're more different. And that suggests that, the microbial communities are different between these two groups. And then we also see some differences among the wildland species if you go up along this axis as well. And then if we look further within those host species, we found this really interesting pattern where the microbial communities in the non-diseased trees, the non-diseased individuals had different microbial community compositions than their neighbors that had been affected. So the results raise some intriguing questions, and a lot of this is going to be corroborated by this richer data set that we have for the metabarcoding. And the questions is, once these trees are attacked, are those microbiomes changing, or do pre-existing differences in the microbiomes in these trees protect them or make them more susceptible. And so ultimately what this does is, this is, things that we're looking into, but it raises the possibility that there are some microbes in there that are actively protecting trees from attack. So what we did is we took this a step further and we tested these fungi and bacteria. We basically got them in pure culture and we tested them for inhibition of the Fusarium pathogen in a culture experiment. And so we placed basically this mycelial plug of Fusarium in the middle of an agar plate. And then, so these are different bacteria isolates that we recovered, and we put those in the margin around the plate and then allowed them to grow. So the plate on the left here is a Fusarium culture without endophytes, and the plate on the right is a treatment where we have isolates that are causing inhibition, indicated here by the red arrows, which basically they're exhibiting this kind of zone in inhibition. You have these antibiotics that are diffusing through the agar, and they're preventing the mycelia from growing to the edge of the plate. Whereas this isolate here, or this particular bacterial species strain, could not prevent the mycelial from advancing. And so the mycelia grow to the edge of the plate. And we also saw, so there's the antibiotic inhibition that we saw, but we also saw this range of interactions between the fungi and the Fusarium pathogen, including, let's see, competition, as well as coexistence. So, some of these species had no effect on the fungus. They just, and either or, they just kind of hung out. Some are competitive and some actively inhibit the growth. The thing with the inhibition and even with competition, what's important about all of this is that the beetle is feeding on the fungus, as Bayes so nicely laid out for you. They're not eating anything else. They're not eating the wood. And so if you can inhibit the growth of the fungal pathogen, then there's potential to inhibit the ability for the beetle to establish onto a tree and further spread. So again, taking this one step further, we took any of these endophytes for this bacteria that exhibited, in this case, antibiotic inhibition in vitro as our first pass, and inoculated them into avocado and sycamore seedlings, allowed them to establish. And then once they were established, we inoculated them with the Fusarium pathogen to see if they could colonize the seedlings. And then we looked at them 3 months later. We tried to re-isolate the Fusarium from the woody tissue. And so this graph is showing trees that we re-isolated Fusarium from the seedlings. And what this basically gives us is an indication that when seedlings were co-inoculated with these bacterial endophytes and the Fusarium pathogen, they inhibited the establishment of Fusarium, the pathogen. And again, this is important because it is inhibiting the food source for the beetle. So if the microbial communities interfere with fungal growth, it protects, again, can protect the individual tree and reduce the spread of the disease. And so things that we're working on right now, and where we see this having the most immediate application, is in restoration settings, where you can manage the microbiomes of organisms before they are planted out into the wild. And so, for example, we're working with this vacuum infiltration techniques to deliver bacteria into cuttings of willows. So we recover the bacteria, we take the cuttings of willows, and then we try to use this vacuum infiltration technique to suck the bacteria into those cuttings, propagate them, and hopefully outplant them into the wild. And so we are testing to see if this approach is effective. And so ongoing research, we are working in collaboration with Jason Stetch at UC Riverside, and we're looking at not only just what's there in one snapshot in time, but we're seeing if there's changes in the microbiome over time. And then the next phase is also to test not just more kinds of endophytes and different species of native plants, but also testing different combinations of microbes, both local and ones that are commercially available, to see, if there's some kind of magic cocktail that we can put together to protect our trees. Okay, so now moving on to predicting Fusarium dieback invasive shothole borer establishment in California. What I'm going to talk about today is how we developed a model to do that, and then how we have recently applied that model and where that is going. So typically when we want to predict the presence of pests, we look at, let's say climate envelopes, and those locations that have optimal conditions for that particular pest are going to be at greater risk for their establishment. But as we all have heard over and over again, this pest pathogen complex has a very broad host range. And we have established and documented that the evolutionary relationships can tell us a lot about the host range, because more closely related hosts are more likely to be severely affected than those that are less closely related. And because Fusarium dieback hosts are distributed over this complex landscape, where some sites have one species, let's say an avocado grove, and others have a lot of species like the ones in this, natural forest, we wanted to use this evolutionary understanding of host relationships to predict which locations the beetle and the pathogen are most likely to establish and cause the most damage in California. So to do this, we established a large plot network in infested and non-infested location in peri-urban and wildland forests, as well as avocado groves, to incorporate the whole range of environmental conditions over which the beetle and fungus are able to thrive. These plots are established from San Diego County all the way up into Ventura County. We also collected microclimate data in each of these, and then we measured the amount of disease present on each tree species. And if some of you were here yesterday, John Kabashima, when he was talking about the model that I developed and how I just could swoop in because everybody did the heavy lifting and everything, I just want to point out that this was a lot of heavy lifting to develop the model, less heavy lifting to apply it. And so I just have to really acknowledge my team here. Between rattlesnakes, poison oak, and yellow jackets, and very long days, we had a really dedicated crew to make this happen. And so I'm super, super grateful for their contributions. So basically, the way that works is that we estimated site susceptibility based on this interaction between what we call phylogenetic structure. Phylogenetic just means, the phylogenetic structure just means the way that the relationships among these different tree species at a particular site, and that interaction with host abundance. And so if you say you have a site here, this is our little plot, and it has these various kinds of species there. We estimated the site susceptibility by taking the probability that a species is a host by basically calculating the phylogenetic distance. So this thing that looks like a Death Star here is a phylogenetic tree. And that is just showing the relationships of all of the different tree species that occur in California. And so we use the phylogenetic distance between each species and the confirmed hosts. And that's how we calculate the probability that it's a host. And then we weight that by the abundance, how abundant each species is. If you're interested in seeing the math, we can talk about it at a later time. But essentially, from our we did this logistic regression, and we have this predicted probability that a site is infested here on the y-axis. And the observed infestation in the plots as well against this susceptibility based on phylogenetic composition of the community on the x-axis here. And basically, we have this highly significant effect at which the probability that a site is infested increases with this increasing phylogenetically weighted host abundance. And another way of looking at this is if we look at the histograms of our infested plots, looking at the total number of infested and the total number of non-infested plots on that same x-axis here. And there is a skew where the area where we predicted plots to be infested are actually infested. And more of the non-infested plots over in reality land kind of in those lower probabilities there. And so the community context alone is doing a pretty good job of predicting things. Of course, it doesn't capture everything because there are sites here we don't expect to see disease and we do, and sites over here we expect to see disease and we don't, at least maybe not yet. You know, this can be an artifact of time, that the beetle just hasn't gotten there yet. But we also know that climate is an important constraint on its development of the development of the beetle. And so we know from previous work, particularly in Tim Payne and Richard Stouthamer's lab, that basically beetles produce more generations per year with warmer conditions. And because we have temperature measurements in all of these plots, we could estimate the number of beetle generations per year for each site using a degree day model. And these parameters that Stouthamer's lab and Payne's lab basically established for these different beetle species. And we could use them to estimate the number of beetle generations. And the idea is that we would basically expect that plots with temperature conditions that are falling more often within this optimal range are going to support more beetle generations in contrast to this non-infested plot. And so what I want to say here for brevity's sake, without going into all of the details, is basically what we found is that areas that have these less favorable host communities, they can become more susceptible if the climate is highly favorable for beetle development. But if the host community is highly favorable, microclimate is actually not as important in determining susceptibility. And so that's really the take-home message. The exciting thing I want to get to here is we have this phylogenetically informed predictive model that can be used as a powerful way to assess risk and guide response priorities. And what we are doing with it currently is part of a big team collaboration between economists. So you just heard Karen Jetter speak, who's taking the lead on this bioeconomic modeling of Fusarium dieback invasive shothole borers in California. We're working with urban forest ecologists, geographers at Cal Poly, UC Davis, Forest Service, Davie, and integrating this susceptibility modeling into the bioeconomic models to inform management and monitoring decisions. So how we applied this model was that basically we used this model that was validated with actual data and a large data set from, I forgot to mention, we surveyed 15,000 trees. So didn't sleep a lot. And Dr. Natalie Love from Cal Poly basically we have these tree inventories in cities across California. And so she was able to compile all of this tree inventory data and in these grids. So this is just an example showing here in Orange County, where you have this grid at the 1 kilometer scale. And again, you have all of these different trees and different tree species. And so we basically applied the model that we developed into these grids for 170 cities in California with complete inventories. Natalie compiled the counts in 9,430 grids. She basically counted over 5 million trees and 1,000 species And we applied this model. And this is just kind of looking at what that actually looks like. All of these different dots are different trees, what that would look like in a grid. And we get this susceptibility map. So what you're seeing here is a map of California. And we have these clusters here of all of the cities that have complete inventories in California. And basically what these clusters represent is locations where the beetle could, these are cities where there's a lot of human activity and movement, where plant material can get transported from one place to another. And so they represent these clusters that a beetle could establish and clusters from where the beetle could spread. And this WPS is basically short for the susceptibility of a site. So if we zoom in here and look at Orange County, for example, so lighter yellow means it's a less susceptible grid, and the darker it gets, it means that it is much more susceptible. And so you can identify on this map here these different hotspots for disease. And then if we take this up into Northern California, where we have not detected the beetle yet, you can see in this area where we have these complete inventories, there's a lot of hotspots here, which is very interesting and important to know. And this is looking at the Bay Area here as well, just kind of another area. Again, you have areas that could potentially be hotspots or that are really just highly susceptible if there was movement of plant material into these areas. So because we don't have complete tree inventories, obviously, to fill the entire state, what we did was we created an additional map. And like our plots, we estimated the number of beetle generations that could occur within a kilometer grid scale. So Alan Hollander from UC Davis basically downloaded a 20-year data set of minimum and maximum temperature from this DayMet data repository. And he ran the programming and the code to estimate the number of beetle generations that could occur within each of these grids. And just so you can see, this is looking again in Orange County. These are the city inventories. And so, if you overlay these maps, you can kind of use them both as a tool to guide, maybe to fill in some gaps. And so this is what the map looks like when you overlay the beetle generation estimates onto that. So the darker blue are areas where you'll see more beetles, and the green, you'll see hardly any beetles. And so just a couple of things to highlight here. The Central Valley is right within this kind of range of, 5 to 7 beetle generations, which is actually a lot. And then you have areas here, Palm Springs, which is, super dark blue. And then the lighter green, you would see less beetle generations. And so just to zoom in again, here is what Orange County would look like. And I'm just going to breeze through this. This is, what Sacramento County would look like. And here's what the Bay Area looks like. And so you can kind of see when you put them next to each other, what these areas look like in terms of the microclimate and the impact on the beetles in conjunction with the tree composition information. And so we hope that this tool will be helpful for identifying locations where control treatments will be most effective. We hope that it can be used to reduce environmental impacts of systemic pesticides by targeting their use and determining appropriate locations and tree species of which costly tree removal measures would be best implemented. And specifically, what we're working on right now with the larger team is as part of the statewide monitoring program is trying to basically prioritize based on where the hotspots are, how best to allocate resources and time and energy towards trapping, and where should we expand trapping and in areas maybe that were less prioritized previously. So what we're doing here in this continuous research is Karen is leading the charge on using this to do a cost benefit analysis, trying to determine where to put traps, and based on kind of where we see those hotspots. We're working on expanding our inventory data. So just again, you can see Central Valley looks like it could be a potential corridor. So it would be really nice if we can fill in those gaps with either more ground truthing or integrating more databases. I'm working on kind of from a theoretical standpoint, integrating landscape considerations into the model to incorporate the important factors such as landscape connectivity. And moving forward, we want to really do simulations to look at changes in susceptibility based on future climate projections, and also continuing monitoring those plots that we use to build this model in the first place, and continue to monitor those so that we can do epidemiological modeling of predicting spread over time as well as spread across California. And so just with that, I'd like to really thank all of you for your time and attention. Big thanks to the Invasive Species Council of California and all of the other folks who have supported this work over the years. And I'm just going to leave a few websites and my email address, and I'm happy to take any questions.
Thank you, Dr. Lynch. We do have a number of questions and just a couple of minutes to see if we can get some answers. The first question is, what do you think the impacts of mega drought might be on the microbiome seeded restoration projects?
Oh, that's such a good question. So it depends, so changes in environmental conditions are going to change what species you have and how many you're going to see there, right? So that's why it's really important to monitor. And that's why we're looking at even what the changes are within a year between wet and dry times of the year, what that's going to look like. And that's going to give us probably an indication of how the microbiome will look and what we can do in a restoration context to mitigate some of that.
So a lot of what you talked about in terms of the various endophytes focused on bacterial endophytes, will you be testing fungal endophytes as well?
Yes. So bacteria, we started with the bacteria because they're just a lot easier to manipulate, but we are working on best delivery methods and the best ways to introduce these different fungi into the plant.
We've got some questions about the model and how it can be accessed, or who should people reach out to if they want to learn more about the model?
You can email me, and Bea and I want to try and get this up and have this kind of as an interactive tool for folks on the ISHB.org website. So keep pinging us and we will keep you posted.
Okay. We have a number of other questions. Maybe you can look in the Q&A and respond to some of those that way. Our next speaker, whose name appeared on a number of those source materials that were just quoted, is going to be talking about emerging research in biocontrol for ISHB. Dr. Richard Stouthamer, professor of entomology with University of California, Riverside.
Thank you. Okay. Yeah, I'll be talking about biological control and explain a bit about what biocontrol is. But before I start doing all of this, I have to also acknowledge a whole bunch of people that have worked with us over the years in order to do this work. And so it's people in my lab, people in Taiwan where we do a lot of field work, and then folks from the Huntington Garden and Keith, who is now at UC Davis, but used to be here in Riverside. And our work has been supported by the state of California, the USDA, and the Avocado Commission early on. We have a problem. We have a pest, and it's spread out over a really wide area in urban forest, in agriculture, and in natural areas, riparian trees. So how can we deal with these kind of pests? How can we come up with a control method? Well, we first got to learn a bit about the life history of these things. And there is a problem with their life history when it comes to controlling them. And one of the problems is that they spend most of their lives inside trees and only a very short period outside of trees. And it's only outside of trees generally where we can easily control these things by spraying insecticides. Okay, so most of their life is spent inside trees and only a short period outside of trees when we can do something to generally kill them. Inside of trees, they're very well protected. Now, another thing is that they produce a very female biased sex ratio. And of course, females are the ones that are going to establish new galleries and new infestations. And then another thing is that often we can control pests by trying to have the females remain a virgin. But in this case, that also doesn't work because the females mate inside the galleries where they're born with their brothers. And consequently, there's nothing we can do about interfering with their ability to mate. And once they have mated, they can start producing all the offspring they want. Next thing is that they have a very high reproductive rate. So it's sort of what I've called before the perfect storm, but then in the form of a pest. It is a pest that is really difficult to control because it has all these attributes that interfere with our general ability to control things. So you've no doubt heard a lot about this already, but so what happens with these beetles? What is their life history? They start, once they land on a tree and it's a suitable tree, they start boring galleries. And these galleries, these tunnels, take several days. They start out by going straight into the tree and then they start to follow the circumference. So they make these galleries and they transfer the fungus that they've carried along from the gallery where they were born on the walls of the tunnel, and that's where the fungus starts to grow, and eventually it will produce the spores that the beetles, and so the mom and her offspring will feed on. So the egg laying starts about a week after the gallery has been initiated. Eggs are laid on successive days. Eggs hatch and larvae feed on the fungus. The new adults are born after, or become adult after about a month. And the brood size is typically 20 to 50 individuals, at least when we measure it in the lab. So they can produce a heck of a lot of offspring. And as I said before, the sex ratio is very female biased. And how can mom arrange that? Well, these beetles have a sex determination system similar to bees and ants, where mom can decide to produce a daughter by fertilizing an egg, or if she wants to produce a son, she doesn't fertilize the egg and it becomes a son. And what she does is she produces a heck of a lot of Barbies and only a few Kens. And the Kens that are born have to inseminate all their sisters. And by the time these sisters leave, they have been inseminated, so they don't need to mate anymore. And this, of course, does not allow us to interfere with their mating, which is, for instance, done in moths, where we place pheromones in the environment to avoid females from becoming mated, and in that way suppress their population growth rate. Okay, now these things can grow really fast. And let's say that we have here in Southern California 5 generations per year. And if a single female mates, lands on a tree, initiates a gallery, and only 2 of her daughters remain on that tree, then after about 2.5 years, there's going to be roughly 30,000 galleries on that tree. So these can grow really, really fast. And if 5 of the daughters remain on the tree, then it's after about 1.5 years that there are, well, in this case, roughly 90,000 galleries on the tree. So it can grow quite exponentially. Now, we know that they can cause havoc, wreak havoc in various places. And this is the Tijuana River Valley, where they killed a heck of a lot of arroyo willows and other willows. Of course, at the moment, it doesn't look like this anymore. The trees are growing back, and we actually have a really hard time finding beetles there, even in trees that are still standing and are still mature. So what can we then do to control a pest like this over a wide area? Well, it seems like that we've landed on the method of controlling them where they cause economic damage by using pesticides in let's say in parks and in homeowners' property. Area-wide control programs, like for instance, are done for the fruit flies using sterile insects, are not possible because the females already mate inside the tree. Trapping using pheromones or pheromones, where you can trap most of the individuals away, also doesn't work because even though we have a lure, it doesn't work so well that we can reduce the population by trapping them away. So one of the few methods that remains is biological control. And okay, well, here it's why it's so hard to control them with chemicals. You need to really inject the chemicals in the tree or soak the soil. And all of these methods, of course, are not that environmentally friendly. And furthermore, the beetle sabotages the water transport in the tree, and you need the water transport to move the pesticides through the tree. So in addition, the beetles eat the fungi. So if you try to get an insecticide into the tree, then the insecticide needs to be taken up by the fungus before the beetle is affected by this pesticide. And of course, controlling the fungus is possible and has been shown to be useful, but you need to inject materials into the tree or soak the soil with this material, all not that environmentally friendly. So biological control. What is biological control? Well, it's based on the principle where you reunite the pest with its natural enemy that more or less keep it at a lower level in their native range. And you can use pathogens for that. So here you see an example of a fungus that is growing on this beetle. Or you can use predators, but both of these natural enemies generally have a wide host range, and we don't want to use them because they will also affect other insects or other parts of the environment that we may not want to affect. So generally what we choose are parasitoids. They have often a very much narrower host range, so they will only attack one or a couple of insects or host species. And they do that. Here you see a wasp. So it's a parasitoid wasp. It has its ovipositor stuck into this fly pupa, and it lays its egg through this ovipositor onto the fly pupa. The larva will hatch, eat up the fly pupa, and out of this dead fly, new wasps will emerge. And so the whole principle of this is that, as you can see here, so this is before the pest population is really high, and now we introduce the a natural enemy from abroad, and then that reduces the pest population to a much lower level below the economic injury level. So this is the principle, and it has worked in a number of cases really well. Here in California, there's the Cockney cushion scale that was a famous example, and the ash whitefly not too long ago. Anyway, this can work really well, but we first need to find out where these things are coming from. And we figured out that they come from Southeast Asia. And it appears that in Taiwan, all the different species of shothole borers occur. So we've gone there a bunch of times to find natural enemies, then send them back here to California, try to rear them in the insectary, and we found 3 potential natural enemies that could be used for biological control. So here you see Akif sawing an avocado tree in Taiwan. Then we take these little pieces back to our hotel room. The hotel management didn't really appreciate that we were doing it in the hotel room. Anyway, this here is Dan Barry from the Huntington, and we then collect the pieces and send them back to our quarantine facility here at UC Riverside. And then we take these individual pieces of wood that have beetle galleries in them and put them in separate cages and wait for the parasitoids to come out. And it appears that the species we find are new to science. They are unknown before. Nobody had seen them before. And here is one that is relatively common, and it's called Eucosmophorus. Here you see a female parasitoid. And what these females have, they have these big jaws and an ovipositor. This curly bit here is the surrounding of the ovipositor. And what they do is they grab the beetle by the neck, as it were, and then insert their ovipositor into the beetle, paralyze them, and subsequently lay an egg. The larva consumes the adult beetle. They form a cocoon on the outside of the dead beetle inside the gallery, and over time, a new adult emerges. Now, it's proven really difficult to rear them, and we can get a number of generations reared in the laboratory for this species. The problem is that they start producing a more and more female-biased sex ratio, and of course, after you want females because they can maintain the population. The males, the only thing do is they mate with the females, whereas the females produce the offspring. And so this particular species has proven to be quite difficult to keep on going. Now, here is a second species that we found, and this is the one that we have the best hope for. This species is also new to science, and here you can see a female. This here is her ovipositor, so through which she injects an egg into the host. Now, what is interesting about this species is it will attack the beetle once it just starts to excavate her gallery. So we generally find them when they just entered the gallery and maybe or started constructing the gallery and are about maybe a centimeter or half an inch into the tree. And so they lay their eggs in the beetle. The beetle dies pretty shortly after that. And then out of one beetle, you can get up to 2 wasps, and a male and a female. And so these things generally have a better sex ratio. So they will produce 1 male and 1 female. The females will produce 1 male and 1 female per host. And you don't have that problem with the sex ratio like in the Eucosmophorus species. And it's a sex ratio that remains that way over the generations. And we have been able to rear this particular species for 4 generations in the lab, but it was a declining population. So we hope now in the next year to establish the lab cultures. And we will do that here at UCR, at USDA APHIS. We're cooperating with them. with a lab in the East Coast that has a lot of experience rearing parasitoids of wood-boring insects. And we're going to do it in Taiwan. Now, we need to have these lab cultures established in order to test how specific these parasitoid wasps are. In order to be able to ultimately release these things in the field, we need to do a whole bunch of experiments to show that they are safe to introduce into California so that they will only parasitize the shothole borers and not some other insects that we that are native or do appreciate. Now, so I want to mention one thing that has been sort of noticed here in California and that has also been noticed in the native range of these things, and that are these boom-bust cycles of this particular species of beetle. It appears that in Indonesia in the 1920s, there was a scientist who found a really heavy infestation of the shothole borers in a particular tree species. And the trees were suffering. And he came back about 7 years later, and he couldn't find a single beetle anymore. And of course, in the Tijuana River Valley, we also see this. People have also noticed it. We've noticed it in some avocado groves in where we used to do a lot of experiments. And then we went back to try to find some more beetles. And we had a really hard time finding any. Similarly, in the Ventura River, people from UC Santa Barbara did some work there, and it also went through a really high infestation, and then it sort of collapsed the whole thing. So in Taiwan, we also see that these beetles in specific areas go through big cycles. And so we don't know here, whether here in California, whether this is sort of a boom-bust cycle that is going to repeat itself, or whether it's going to sort of stabilize at a much lower level after some native environmental factors are controlling these beetles to a larger extent. We found here in California some nematodes that feed on the fungus, and they appear to also reduce the population growth rate of beetles in these infected galleries. So it's all still quite a mystery why these things grow so fast here and what we can do to reduce them. We hope that we can establish these parasitoids, but in the meantime, we are also looking at what's happening here in California. And with that, I have reached the end of this talk.
Thank you, Dr. Stouthamer. I don't see questions specifically related to your talk. So if anybody has a question for Dr. Stouthamer, please enter that in the Q&A section. I suppose this is one that you could respond to. Someone's asking about the first generation beetles when they leave the tree. Do they all leave the tree, and do they exit through their mother's entrance hole?
Generally, there's just one hole. The entrance hole is the exit hole. And although in some cases we've now found that there's more than one hole per gallery, they do exit through there. It's not quite clear what they, if they sometimes stay and just start to reproduce inside the natal gallery, that they start producing and laying eggs there. And there's some evidence that they can do that, so that sisters, the daughters just remain in the same gallery, lay eggs. And it also would make sense. I mean, if the gallery is functioning well and if there's lots of fungus, why go and create your own?
With respect to the parasitoid, have members of the parasitoid genera mentioned been used successfully in other biocontrol programs?
Yeah, so this particular genus is being used against coffeeberry borer, which is a pest of coffee berries. And there's also, now just recently, they discovered another species of this genus in Hawaii that is working against another relative of the shothole borer. It's just occurring there, and so it's not been introduced on purpose. It just came with the beetles.
All right, thank you very much. Excellent talk.
Thank you.
So I'm going to wrap up the presentations with a discussion on ISHB-related education and outreach.
Well, I was going to introduce Randall, so he didn't have to introduce himself. So while you look for your
Thank you very much.
I would like everyone to know Randall Oliver. He's the statewide invasive Shothole Borers communications coordinator and working in the University of California statewide integrated pest management program.
I'm going to talk about outreach and education, which is a powerful weapon in our arsenal against the invasive shothole borer and Fusarium dieback. Broad awareness of this pest disease complex and also knowledge of how to recognize it and manage it are keys to finding infestations early on and taking action when it's most effective. Workshops and symposia like this one are obviously very vital channels for such information sharing. And there are a number of other tools available that can help augment what you've learned here and also help you to share information with others. So I'm going to talk about some of those tools, and I'm going to focus on the website, ishb.org. I'll also briefly talk about some other communication channels, which primarily are social media, and I'll explore the question of how can we help? So the ishb.org homepage, which you see a picture of here, contains information and tools that can be very helpful, including a link to the online course, the online detection and management tool. There's a brief overview, as well as an introductory video that can give you all the basics on the pest. There's also upcoming events. So you see here this symposium, and look there in the future for other events of this type, and also a what's new section. And this is basically a repurposing of the shothole borer blog that has existed for a number of years. And this is a way to allow people to find that more easily. And then there's also here at the bottom a place where you can sign up for emails. We plan to really take that up pretty dramatically. So if you're interested in the subject, please do sign up for that. The first tab that you would look at on the top navigation is the Pest Overview. So on this page, one of the key things you will find is the host list. So lots of the presenters have talked about the susceptible hosts, and as well as those that are on the list, but somewhat less susceptible. So you can see the complete list here. This is actually the second most visited page on the website. And another very important thing is the map of the current distribution in California. So that provides a lot of information. You can zoom in on it. You can see where the pest has actually been identified in California, as well as negative surveys and traps. The second tab is diagnosis. So one of the keys here, again, is the ISHB detection and management assessment tool. You can also explore the signs and symptoms of infestations, as well as how they look on the various host tree species. So Dr. Novo Berman talked a lot about this, but this is a great place where you can go and you can really drill down and see which species are affected and what types of symptoms you're going to find on those. There's also some talk about other things that may have signs and symptoms that are very similar to shothole borer, but not identical to shothole borer, and also pest profiles of those various lookalikes. On the management section, there's information about best practices. And there's also links where you can look at various videos on monitoring and sampling best practices, trapping for invasive shothole borers, as well as best management practices for invasive shothole borers. And also under management, there's information about greenways and firewood as well. Very important in controlling this pest, because one of the key ways, as we've talked about, that these are spreading is in infested greenways. The beetles themselves can't really fly very far. So as we're seeing them spread northward and eastward in California, the primary vehicles for them to do that is hitchhiking on firewood and infested greenways. We also have a news and events section, a lot of good resources under education and training. You'll find the online course there as well as recordings of various previous online webinars and workshops. And at some point in the near future, you'll find links to watch the video recordings of this particular symposium. There's also a news archive, and it's pretty impressive how much has been written over the last few years on the invasive shothole borers. And so we're hoping to see more of this going forward, of course, but there is already a pretty substantial library there. There's also sections of resources that include primary handouts and materials. And these are primarily different types of materials that have developed within the UC system, as well as from some of our key partners. And there's supplemental materials that are also helpful through another tab. Also under resources is our photo library and a link to other organizations that provide materials or are somehow related in this battle against the shothole borers. There's also a context section, and here you can look at UCCE offices by county or agricultural commissioners' offices by county, as well as get the contact information for the various RCDs throughout California. And of course, there's other ways of keeping up to date on information and staying in contact about invasive shothole borers. And one of the key areas there is social media. So these various channels exist now for shothole borer. We have Twitter page, Facebook, Instagram. All of these have been rebranded recently with the name ISHB update to allow you to find them more easily than they were available in the past. There's a number of other outreach organizations that are doing work in this area. Dr. Nobura Berman's been very instrumental in establishing master gardener groups with a focus on invasive pests in general, invasive tree pests. There was already one existing in Ventura County. Now there are also groups in Los Angeles County and Orange County. And ideally, over time, these groups will be present at master gardeners throughout the state. There's also some other groups that do ongoing information, communications, research that are available. The primary way to access these is through collaborative tools in UC Agricultural and Natural Resources. If you're interested in these, you can shoot me an email. I'll provide my information in a second. But these groups are really good at keeping people informed about what's taking place with various pests in the given area that they cover. So how else can we help? That's really what we're here to do. That help can come in many forms, such as providing presentations and training. We're always interested in opportunities to reach out to various groups, and whether we do that online through a Zoom presentation like this or in person, we are always willing to do that. Event booths and exhibits, we are now becoming as the pandemic gets behind us, we're becoming much more active in various conferences, in events, and communities throughout Southern California primarily. But we're willing to go wherever there's a need. And we have lots of materials and handouts. Those are available in the digital form through the website, but we also have hard copies, and we're willing to provide that to your businesses, to your organizations, in order to have you help us spread the word. And we have ISHB ID kits for those who are actively working in the field on this pest. So lastly, here is my contact information. Please feel free to email me or reach out to me via phone, and I will be happy to take your questions and help in any way that I can. And that concludes all of our presentations for today. So I'd just like to thank everybody for participating in this symposium. I hope it provided you with a lot of good and useful information. And with that, I'm going to conclude the symposium.